Bright Tuty. Every student matters.
So let us have a look at this first question here. The radii of the ends of a frustum of a cone 45 centimeter high are 28 centimeter and 7 centimeter. Find its volume. So let us say this is the frustum in question. The larger radius is 28 centimeter, smaller one is 7 centimeter, and height is 45 centimeter. Right? We need to find its volume and curved surface area and total surface area. So if you look at it from the perspective of a cone, this question is just to explain the theory part, right? Otherwise, I can directly apply these formulae and calculate the volume and surface area, but this question is to explain the working of a frustum of a cone, that it is the difference of area, difference of volumes of bigger cone minus the smaller cone that we are removing here. So this is the smaller cone here that we are removing to make it a frustum. Okay. So this radius is 7 centimeter, right? Now this is a right triangle. This is also a right angle here. Okay. Now if I take this triangle separately, it will look like this, right? This length is 7, this length is 28, this is a right angle, this is another right angle here, right? Let us name these points A, B, C, P, Q. Okay. So what can you say about triangles A, P, Q and triangle A, B, C? Look at it. This angle is common to both the triangles. This is a right angle and this is also a right angle, right? So in triangle APQ and in triangle ABC, two angles are equal. So the third angle has to be equal, right? In triangle APQ, this angle, and in triangle ABC, the same angle. This angle is common to both the triangles. And in triangle APQ, this angle, and in triangle ABC, this angle are equal because both are right angles. So the third angle is also equal, right? Otherwise also these two lines are parallel, right? So these angles are corresponding angles. Anyway, you can think about these angles are equal. So these two triangles are similar to each other. Triangle APQ is similar to triangle ABC because of angle similarity, right? So if this height is 45 centimeter, let us take this height as h, or let us name it as h1. Okay. So what will be ratio of sides of these triangles? AC upon AQ will be equal to AB upon AP will be equal to BC upon PQ, right? Because in similar triangles, ratio of corresponding sides is equal. Okay. So what is AC? AC is H1 plus 45. What is AQ? AQ is H1. It is equal to AB, which we need to calculate when we will be calculating the surface area. We will deal with this AB. Let us name this AB as L1, okay, and let us name this BP as L. So L1 is AB divided by AP, which is L1 minus L. Okay. What is BC? BC is 28. What is PQ? PQ is 7. Okay. So now if I compare these two, H1 plus 45 divided by H1 is equal to 28 by 7, which is 4. So 4H1 minus H1 will be 3H1, it is equal to 45. So H1 is equal to 15. So this height AQ, that is this one, this is 15 centimeter. Okay. So what is the total height of this cone? It is 60 centimeter. This much information is enough to calculate the volume. So, and next set of information will be required when we calculate the surface area. So let us first of all calculate the volume. So what will be the volume of frustum? It will be equal to volume of this bigger cone with dimensions 28 centimeter radius and 60 centimeter height. So volume of frustum will be 1 by 3 pi bigger radius of the bigger cone square into height of the bigger cone, which is 60, minus 1 by 3 pi 7 squared into height of the smaller cone, which is 15. So this will be the volume of the frustum of this cone. This I have done without using that formula, right, which I taught you in the introduction part. So this will be equal to 1 by 3, pi can be written as 22 by 7, and 15 can also be taken as common. So inside I will have 28 square into 4, and here I will have 7 square only. Okay. So to further simplify it, we can take 7 square also as common, 1 by 3 into 22 by 7 into 15. If I take 7 square common, I can write it as 7 into 7. From here 7 square is gone, right. So 4 square will remain inside. 4 square into 4 is 64 minus 1. So now this 7 can be cancelled, 3 5s are 15. So this is 22 into 35 into 63. Okay. So 22 into 35 is equal to 70, so 770 into 63. So 770 into 63. So 0 will remain as it is, 2310. So this is the calculation part which I want you to do yourself. Okay. 48510 centimeter cubes is the volume of the frustum, right. How did you find this volume? We just subtracted the volume of this smaller cone, this one, from the volume of this bigger cone, because this is how I have got this frustum, by removing this smaller cone from the bigger cone, right. So this is the way to find volume of this frustum. In all the questions you won't follow this process. This was just to make you understand how the volume is calculated or how the formula for volume of this frustum will be derived. Otherwise, if you get this question in the board examination, you will just apply this formula directly, okay, and you will find the volume and you will get the same answer, right. Now let us look at the curved surface area. Okay. So let us make this triangle separately. Now we have got this formula here, so let us use this one. L1 by L1 minus L is equal to 28 by 7, which is 4, right. So effectively L1 is equal to 4L1 minus 4L. So this is 3L1 is equal to 4L. So L by L1 is equal to 3 by 4, right. Now look at this. You need the surface area or the curved surface area of this frustum of cone. So now what you will have to do is you will have to subtract the curved surface area of the smaller cone from the bigger one. So what will be the curved surface area of frustum? It will be equal to pi. What is the surface area of this bigger cone? Pi r, which is 28, into the slant height. Slant height we have considered L1 minus pi r, which is 7. And what is the slant height of this smaller one? It is L1 minus L. L1 minus L, right? So pi into 7, if I take common, here I will have 4 L1 minus, this is L1 plus L. So this is equal to 22 by 7 into 7 into 3 L1 plus L. Now look at this L1 and L. Let us find these values. Look at this bigger triangle. This dimension is 28 and this is 60, right? We found the height 60. So what will be the slant height L1? L1 will be equal to L1 square is equal to 28 square plus 60 squared, right? So it is equal to, if I take 4 square common from both, here I will have 7 square, here I will have 15 square, right? So it is equal to, L1 is equal to square root of 4 square is 4, square root of 15 square plus 7 square, which is 49 plus 225. It will be approximately equal to 16.55. So 4 into 16.55 is how much? $66.20. So when I have got L1 as 66.20, it is very easy for me to calculate L. So L will be equal to 3 by 4 of 66.20. Now if I divide it by 4, I know I will get 16.55. So 3 into 16.55. So L is equal to 49.65. So just plug the values here and you will find the curved surface area of the frustum. So this 7 can be directly cancelled here. 22 into 3 L1. So 3 into 66.20 plus L, which is 49.65. So I leave this calculation part to you. This will be the curved surface area of this frustum in centimeter squares, right? To find the total surface area, what you have to do, you just have to add, for total surface area, you just have to add this area, which is pi r square 28 square, and this area, which is pi 7 square, right? This will be the total surface area. I hope this question is clear to you. This was just to clear the concept of frustum of a cone. In rest of the questions, we will directly apply the formula. So now these two fellows, Hanumappa and his wife Gangamma, are busy making jaggery out of sugarcane juice. They have processed the sugarcane juice to make the molasses, which is poured into molds in the shape of frustum of cone, having diameters of two circular faces as 30 centimeter and 35 centimeters. So this kind of mold is there. And these are diameters of its two circular faces. So what will be the radii? 30 by 2, that is 15 centimeter, 35 by 2 centimeter. Okay. So these are the circular faces of the frustum, and its vertical height is also given, which is 14 centimeter. Okay. If each centimeter cube of molasses has mass about 1.2 grams, find the mass of the molasses that can be poured into each mold. So if each centimeter cube, so we need to calculate the volume of molasses. If I know the total volume in centimeter cubes, I will just apply the unitary method, that 1 centimeter cubes has got mass 1.2 grams. So the total volume into 1.2 gram will be my answer. So let's talk about volume here. To find the volume, I will just apply the formula, volume of the mold, which is frustum, will be equal to 1 by 3 pi. Let us say this is R1, this radius is R2, R1 square plus R2 square plus R1 into R2. If this height is h, then multiply it with h. So the volume of the mold will be 1 by 3 pi R1 square plus R2 square plus R1 R2 into height h, right. This was just to write the formula, otherwise I could have directly written the dimensions here. So let's write the dimensions, 1 by 3 pi R1 square, so it is 15 square plus R2 square, 35 by 2 squared plus R1 into R2, 15 into 35 by 2 into height, which is 14. Okay. Each centimeter cube, so this volume is in centimeter cubes. Okay. 1 centimeter cube has got mass equal to 1.2 grams. So this much, if I denote it by V, so V centimeter cubes will have mass equal to 1 by 3 pi, I will write it as 22 by 7 into 15 square plus 35 by 2 square plus 15 into 35 by 2 into 14 into 1.2. So this will be your answer after the calculation part. So let's try to do some calculation here. Let us see if we can make it a little simpler. 22 by 7. I will write this 14 here and this 1.2 here into, if I write 15 as 30 by 2 again, this is 35 by 2, this is 30 by 2 into 35 by 2. Now you see 4 from the denominator can be taken as common, and from the numerator you can take 5 square as common, right. Otherwise, if you know the squares of these directly, 30 square is 900, 35 square is 1225. You can write the squares directly here also. So 7 2s are 14, 3 here will give 0.4, so this is 0.8, 176, so this is effectively 17.6 here into 1 by 4 I have taken as common. From inside I can write 900 plus 1225 plus 30 into 35, which is 1050. Okay. So it is equal to 17.6 into 1 by 4, and what is this here, 5 7 2 2 plus 900. So this will be equal to Now I can cancel here it by 4.4. So 4.4 into this will be equal to 75 in the end. 9 plus 2 is 11. So this is 3175. Now you just need to multiply 3175 with 4.4 and you will get your mass in grams. Okay. So let me multiply this to get you the final answer. So this will be equal to 13970. Okay. 10 you have to remove because I didn't take this decimal into consideration while multiplying. So you will have to remove 10. So this much grams is the mass of the molasses. Okay. So I directly applied the formula in this question. Now we have got an open metal bucket in the shape of frustum of a cone mounted on a hollow cylindrical base. So what will be the shape of this bucket? It will be something like this. So there is this frustum, right? It is mounted on a hollow cylindrical base. So this base will be like this. This is a cylindrical base, right? So this is the bucket in question. Now diameters of two circular ends of buckets are 45 centimeter. So the radius here will be 45 by 2 centimeter and radius of the smaller circular end, smaller circle will be 25 by 2. So this radius here is 25 by 2 centimeter. The radius of this smaller circle or the bottom part of this frustum will also be the radius of this cylindrical base, right? Total vertical height of the bucket is 40 centimeter. So this height is 40 centimeter and that of the cylindrical base is 6 centimeter. So this much is 6 centimeter. So what is the height of this frustum part of this? 34 centimeter. Right. So what is the height of the frustum of this frustum part of this bucket? It is 34 centimeter and the cylindrical base has got the height of 6 centimeter. Okay. Find the area of the metallic sheet to make the bucket where we do not take into account the handle of this bucket. So for example, let us say there is this handle of this bucket. This we don't have to consider. Also find the volume of water that this bucket can hold. So volume of water is simple. Volume of water is just the volume of frustum, right? Because the water will be held in this part only, the frustum part. So it is equal to volume of the frustum of this cone, which is equal to 1 by 3 pi R1 square plus R2 square plus R1 R2. So 25 by 2 square plus 45 by 2 square plus 25 by 2 into 45 by 2 into height of the frustum part only, which is 34. So this is the volume of the frustum, or we can say this is the volume of water that this bucket can hold, right? You can further simplify it. 1 by 3 pi 1 by 4 can come outside and this 34 you can write here so that you do not forget it from the calculation, and 25 square plus 45 square can be further simplified by taking 5 square as common. So you can take 5 square here and 5 square will give you 25 here, 9 square will give you 81 here, 5 square we have taken as common, so 5 from here and 9 from here. will give 45 here. Okay. So 1 by 3 pi into 1 by 4 into 34 into this 25 plus 25 into this is 45 plus 25 is 70, right. 70 plus 80 is 150, 151. Okay. So this is the calculation part which I leave to you. This is in centimeter cubes. So the volume of this bucket or the volume of water that this bucket can hold can be calculated in liters. So for that you will have to convert it into meter cube first. For calculating the volume of this bucket in meter cubes, you will have to divide it by 100 into 100 into 100. Now this volume is in meter cubes, right. So I have converted into meter cubes. Now if you want to convert it into liters, you will have to multiply it by 1000, because 1 meter cube will have 1000 liters in volume. So this is the volume in liters that this bucket can hold. So effectively you will do this calculation and divide it by 1000 to calculate the volume in liters. Okay. Now another part was to calculate area of the metallic sheet to make this bucket. To make this bucket we have to make two parts essentially, this cylindrical bottom part and this curved surface area of the frustum and this base. Okay. So to calculate the curved surface area we would require the slant height of this frustum. So let us consider this as L, and if I drop this perpendicular here, I will get this right angle triangle. This distance is 45 by 2 minus 25 by 2, which is 45 by 2 minus 25 by 2 is 20 by 2, that is 10 centimeter, right. This height we already know is 34 centimeter. So L square is equal to 34 square plus 10 square, right. If I take the square root, it will be 34 square plus 10 square, and it is approximately equal to 35.44 centimeter, right. I want you to do the approximation yourself. This is 35.44 centimeter approximately. So now I have got the slant height of this frustum part. So now I can say I need to calculate the area of metallic sheet. So area of metallic sheet will be equal to curved surface area of the frustum part plus curved surface area of the cylindrical part plus area of the bottom of the bucket. We can say circular bottom of the bucket, and you have got all the dimensions that you need. Curved surface area of the frustum part can be written as pi r1 plus r2. So 45 by 2 plus 25 by 2 here into slant height of the frustum, which we have just calculated, 35.44. So this part is done. This is the curved surface area of the frustum part plus curved surface area of the cylindrical part, that is 2 pi radius into height. So 2 pi, what is the radius of the cylindrical part here? This cylindrical part we are talking about. It is same as 25 by 2. So 2 pi radius into what is the height of this cylindrical bottom? It is 6 centimeter. So the curved surface area of the cylindrical part is also done. Now area of the bottom of the bucket, that is circular bottom, that is this. Okay. What is its area? It is pi radius square. So pi, what is the radius? 25 by 2 square. So this is the area of the metallic sheet that you would require to make this bucket here, right? And this area is in centimeter square. I can safely leave the calculation part to you, right? Because the calculation is simple, right? Even if the calculation is difficult, it is for you to practice it, okay?